Hi, and welcome to Tea Leaves Programming. Today we are programming like it's 1979. You're watching Haskell for Dilettantes. Now, if you're not familiar with the word dilettante, it means one who dabbles in art or a field of knowledge. Someone who knows a little bit about a topic, but isn't actually an expert. And I think that's the perfect description for my relationship with Haskell. So I've done a few different surveys of different online courses, in part because I'm very opinionated about how to teach. And the Haskell community, I feel, although well-intentioned, has struggled with teaching materials. In particular, some of the earliest kind of breakthrough teaching materials, which I will not name because I'm not here to slag them. They were very enthusiastic. They were written by people who really clearly loved the subject matter, but didn't follow what I would consider good pedagogy. Someday I'll learn how to say that word. And so every time I see or encounter a different Haskell course, I'm like, ooh, I want to take this and see how it does, and see if this would be appropriate to give to my my friends who want to learn Haskell. So there is a new one. I believe it's fairly recent. It is called Haskell MOOC. It is at this URL right here, haskell.mooc.fi. I'm not going to put it on screen here, but what I do have on screen is my Emacs window. We're looking at the first problem set. And I reached out to one of the creators of this course, Joel Kassinen, excuse my mispronunciation, who developed this course along with Jan Lang. Again, I'm sorry if I'm mangling your name. And asked them, can I use this for the videos? And they're a little bit conflicted. And this is very common with teachers, especially if the class is still being actively given. You really don't want to help people cheat in the course. And I certainly don't want to do that either. And if I do help you cheat in the course, you're largely cheating yourself, right? Like copying the exercises from some dilettante on the internet isn't making your experience any better. It's not helping you learn. But I'm not doing these exercises to get to the answers. I'm doing these exercises as an excuse to talk about the aspects of the language that I find interesting. So the compromise we arrived at was that I'm going to go through this and I'm going to do the entire course myself on camera, but not broadcast. You don't get to see me doing the entire course. And then I'm going to go back and I'm going to pick one or two exercises per chapter. Each chapter has many exercises, so I'm not giving away too much. And I'll take the most interesting exercises, where interesting is defined as I had the most to say about those particular exercises, and I'll edit those together into a video, which you would then watch, and presumably you're right now watching the first one. So I hope that works out. Once again, if you are taking the course, please don't watch these videos until after you've done the exercises. If you're not taking the course, have at it. And, maybe go to haskell.mooc.fi and do the exercises before I do, and then come back so you can complain about how many things I got wrong, which will certainly be many. All right. Let's get going. Each chapter comes with a set of tests, so you could run the tests. At this point, I've done none of the exercises, and that will essentially auto-grade the test for you. And that is great if you're a self-directed learner, as I am. I already see an issue for myself. If I'm only going to show you one or two of the exercises here, then I have the problem that I need to make sure that if I've decided to broadcast exercise 13, that I don't accidentally show you the answer to exercise 12. So I'm going to add a bunch of line feeds, so hopefully that doesn't happen. If I mess this up, if I accidentally show you the results for exercise 12, or rather the answer to exercise 12 when I'm doing 13, please let me know so I can redact the video appropriately. There is actually something really good about doing this offline, so to speak, and then only showing you the good ones, which is sometimes I get stuck. And, you know, I'm a believer in showing you the places where I get stuck when it's interesting. But sometimes just having video of me staring at the camera going, I don't know. That's not great video and probably doesn't help you learn either. So this gives me a chance to read the entire chapter carefully before doing the exercises, as one always should, and then only show you the parts where there's something good to discuss. The first chapter is excellent. The velocity of it, I really appreciate. It moves at a brisk pace without using too much shorthand. It covers everything you need to know to get started, but it does it in a snappy way. They also recommend some other course materials and also opine on how they are. They give some definitions, and then they start going through the language features. One of my objections to Haskell Programming from First Principles, which is an encyclopedic work, is they really delay introducing a lot of the language syntax until they're talking about more abstract issues. And I think that's a real shortcoming because you're trying to wrap your brain around some abstraction, and then suddenly they start talking about, may not be a specifically correct example, but they'll start talking about guards or some other language issue in the middle of that. This really does cover quite a lot of the syntax, the basic syntax, in one chapter, gives a bunch of examples, even talks about how to handle errors and how to read a Haskell error message, which is a necessary skill for if you're going to be using the language in anger. Talks about let and where. So it's a very good introduction. So having seen that and having read it, let's go on to the exercises. And which ones am I going to pick to show you? Let's find out. To find the function distance, it should take 4 arguments of type double, two 1s and 2 2s, and return the Euclidean distance between points x1, y1, and y2, x2, y2. Give distance a type signature. Okay, great. And it's the Pythagorean theorem, right? So it's a squared plus b squared equals c squared, and we are looking for we can calculate a squared and b squared. All right, so first this is the first exercise where we need to write a type signature. So a type signature is the function name and this colon, which is read has the type of. And we're going to be taking 4 arguments, and they're all doubles. 1, 2, 3, 4. And then it's going to return a double. 5. All right. Square root of x distance. So do we need to write a square root function? I don't think we do. SQRT is our square root function. So the Pythagorean theorem is a squared plus b squared equals c squared. And we want the square root of c squared. Okay. I don't know if we need like math.square root. I guess we'll find out. The square root of c squared, where c squared is equal to a squared plus b squared, where a squared is, let's see, x2 minus x1 squared, and b squared equals y2 minus y1 squared. Obviously, I did not need, it could have done this all on one line, but I like using the where syntax. I like using the let syntax less, even though it's arguably usable in more situations. So one task I kind of have for myself is I'm recognizing this preference for where is actually a slight weakness in my kind of heuristics for how I write Haskell. So I'm not going to do it right now, but at some point I'm going to try and teach myself to start preferring let. All right, and let's run this test again. All right, variable not in scope. Oh, okay, yeah. Well, that was silly. I have to actually bind these things to names. X1, Y1, they're coming in this order. X2, Y2. All right, now we've got them. I ran set1 instead of set1 test. And exercise 4 has passed. All right, exercise 10, power nk should compute n to the power k, i.e. n to the k, use recursion. And they've given us a type signature. All right. I will use n and k for my variable names. I complain a lot about variable names. I often complain that the Haskell idiom is to use single variable letter names that are maximally abstract, and I don't like that. But in a case like this where, it literally is a math problem, and these are the names of these as defined in the problem, in that case it makes sense to use names like this. So first of all, actually, before I even do that, we should be handling our base case. And our base case, well, what is our base case? Our base case would be n to the 0, logically, which would be 1. Anything raised to the 0th power is 1. One way to get this wrong, and I don't know if their auto checker is going to get it, is there's nothing here saying that k has to be positive. So we need to handle the case where k is above 0. I don't know why I had trouble coming up with that word. And we need to handle the case where k is below 0. So what does it mean? You're gonna make me remember my pre-algebra. What does it mean to have a negative exponent? I want to say a negative exponent is flipped. You're kind of dividing by that value. Yeah, I'm pretty sure that's the case. So let's do this. Let's use an if here. We can't pattern match on NRK. We can't use guards. This is another case where I would prefer to use guards. So if k is 0, then what? Then it's going to be n times power to the k minus 1. But if k is not greater than 0, then either k is 0, which we know is not true here because we have a case, we have a pattern looking for that. It's going to be n divided, and this is integer division. So we have to use the div operator, not the slash. Power k plus 1. I don't even know if they're going to test that or not. Let's find out. What did I get wrong? Power is applied to too few arguments. Right, because we have to pass in our n. See, that's a good example of a good mistake. I like making mistakes, because I think very often when you're watching online materials, especially for certain reasons in the functional programming community, people like to pretend they're beings of pure energy that never make mistakes. Well, now I'm curious. And I'm specifically curious whether they would have tested for the negative power case. So Let's try it. They did not. All right. So I'm going to stick to my guns here. The problem does not say that k must be positive. Therefore, I'm going to handle the negative case. All right. So it's a good thing for me that they didn't test it because my implementation is wrong. The plot thickens. Oh, because I'm using integer division. Right there is the answer. I don't think this can be answered for negative numbers. Right? In order to be able to answer it for negative numbers, for negative exponents, we need to return a double. We need to do this. All right, this actually makes sense. If I'm going to change the operation, division is not commutative. I needed to swap the order in which I was dividing. Be that as it may, my recommendation is they should add the word positive, where k is greater than 0 to this problem. It's a fun little puzzle, though. It's fun to think about how it should work if k is negative. In order to get a correct answer for the negative exponent case, we would need to change the type signature, and this type signature was given, but I'm uncomfortable leaving the negative exponent case completely handled. In fact, because with the solution that I wrote, it would infinitely loop. So instead, I opted for this solution where we kind of encode our assumption that k must be greater than 0 or greater than or equal to 0 into the function. And that seems like a reasonable thing. It's the type of thing, if I was writing C code, I might put an assert in there for exactly this type of reason. That way, if your assumption turns out to be wrong, you get a sensible error message explaining what assumption is being violated. All right, so that concludes Lecture 1 exercises from the Haskell MOOC from haskell.mooc.fi. Let me put the link down here one more time in case you missed it earlier. It seems like an interesting course. The challenge with courses like this is always, as you go on, as you get into the more challenging material, what's the ramp like? And how good are they at onboarding you into these more difficult concepts? If you're really thick like me, that's quite a challenge for some of these courses. But we will take a look, and I'm gonna continue pulling this string, and I will see you next week maybe for lecture number 2. You have been watching the channel Tea Leaves Programming. Today we're programming like it's 1979 with Haskell for Dilettantes. Thanks for watching.